So we're going to get started on our day 3 of the bootcamp in week 1, and this is just a general intro to cloud computing as a whole. Okay, the cloud is a terminology that's sprung up fairly recently in terms of computing history. It seems quite complicated and can often be dealt with or explained as a bit of a dark art. But the easiest way to think of a cloud is a computer that's just somewhere else that you don't have to maintain or deal with. It's just someone else's job, and you're paying them for the luxury of them sorting that out and making sure that works for you. Okay. As far as the setup and maintenance and running your application goes, that's down to you to make sure it all works on there, but it's up to them to maintain that. So we're going to talk about what is the cloud briefly, why you would want to use the cloud, common services. Some of the major cloud providers will list those out. The cloud and big data, and the cloud and Internet of Things. I'll try and give a bit of meat on the bones as to what we mean by big data and Internet of Things as well. They're a bit subjective, but it's more of a discussion at that point and getting you used to the terminology and the understanding of what we mean with those. So the cloud is, as I said, a buzzword. Essentially, it just refers to any kind of computing which is done off-site in a data center. Okay. These data centers used to be, a couple of decades ago, just large buildings in city centers generally, to make sure that you had a decent internet or networking connection to those and made the transfer of data easier. Okay. Now, they were local, but they found that it was quite expensive having a lot of computers running up at a very high temperature generally and trying to keep them cool so they don't overheat in the middle of London or Birmingham or Manchester or in New York. So that became really expensive. As internet access and connectivity got better and better, they realized that we could do this regionally. Okay, we'll talk about in a couple of days what those regions look like and the rules that different cloud providers have, especially from a Microsoft point of view, because they have to have redundancy and a secure system in place to make sure that they have a decent uptime. Now, if you think of like reliability, what kind of reliability would you expect from your computer in terms of working? Would you want it, would 70% of the time your computer working and it only crashing 30% of the time be reliable? What about 80%? What kind of figure would you say, you know, how often would you expect your computer to crash and consider it reliable still?
I think that depends on the system, like if it is medical care or any critical like nuclear reactor, then like maybe 100%. But if it is something like just online shopping, maybe above 90.
Okay, so let's break that down. Ideally, yes, a nuclear system would be 100% reliable. In reality, each individual component or system or microsystem inside a nuclear reactor, from a technical point of view and a computational point of view, cannot be 100% reliable because computers rely on moving parts. So as soon as you've got anything mechanical in a system, that's not going to be 100% reliable. But if you mirror that, so you've got 9 computers that are all 99.9999% reliable, then you've got an almost 100% reliable system, assuming that they don't break at the same time, that they independently break. So 1 in a quadrillion chance of breaking. So maybe that's the case. 90% for a shopping website, that might be seen as acceptable for certain shopping areas. If you were Amazon, that certainly wouldn't be acceptable, because could you imagine the amount of business that they would lose if they were down for 10% of the day? It would be it would run into the millions very easily just from UK shopping. Lots of IT providers strive for quadruple nines. It is the industry standard at the moment that we try and strive for, and people like our Moodle providers, because we use Moodle, you may have come across that, to host our teaching material generally outside of Teams. So that has the lectures on the slides, the activities, labs and stuff, as a structured place that we roll on year, so that it's got the same material for the next year and the next year, and we can just make minor updates and things. So that's the standard teaching support system that's used in most UK universities. Now our Moodle provider is striving for what they call a quadruple 9 success rate. So reliability and uptime 99.99% of the time. Okay, so maybe they get a couple of hours of breakage per year. Now there's going to be, obviously, there's going to be more aligned to when it's busier rather than when it's quieter, when you'd prefer it to break down on a Sunday afternoon or in the middle of the night compared to 9 o'clock on a Monday morning when you've got lots of students and staff logging in to do stuff. But that's the kind of level, just to benchmark of reliability that generally you should be expected to work at if you're working in cloud infrastructure. This is part of why we favor the cloud, because you can have multiple machines stacked up that you don't have to maintain, that you're trusting Microsoft or Amazon or one of the other big providers to maintain at incredibly high precision and accuracy for you. And that if something breaks one way at one stage, it's mirrored somewhere else, so that it automatically picks up with the next machine and the next computer. Okay. Now, there are very many different branches to cloud systems, and people specialize in even subtopics of each of these as well. But these are the general topics. So cloud storage, so make sure that your data is secure online off of your computer. It's absolutely something that you should all be looking to do with everything that you've got on your computer, pictures or personal documents or any work things. You should always be doing regular backups to the cloud, ideally. Cloud computing to process. We're going to see this in a couple of weeks as a particular example, but I mostly use cloud services so that I don't bog down my own computer. So I sometimes run very big artificial intelligence models on lots and lots of data. So if I'm processing a model that may take a week to run, I'd much rather do it on someone else's computer that's not going to run out of power compared to my laptop, that's not going to break halfway through. But also I want to do it on that so that I can then focus on my laptop, writing Word documents, responding to emails, doing those general, part of the job things. So the cloud gives you that facility to just set a task going, and the cloud does it for you and doesn't slow down your own machines. It costs, but it's generally seen as worth it. Then we've got Internet of Things. So the cloud facilitates connectivity very easily between multiple different devices in different locations and could be a good hub to collate all that information. So we often have student projects where people are interested in cloud stuff. And just as a really nice basic example, I've seen a student who did a project where they wanted to have little Raspberry Pis, so they're very cheap microcomputers that cost about 30 to 50 quid, and have a series of those in control of an air conditioning system, so that if it got too hot in one part of a very large room, the Raspberry Pi would detect it and change the temperature and the balance across the room to make sure that it all maintained a perfect temperature. And all that happened is those Raspberry Pis just had a Wi-Fi enabled chip, and instead of trying to talk to each other, so 6 Raspberry Pis talking to each other, that's 36 potential communications, they just had to talk to the cloud. The cloud did the clever thinking bit and then told them what to do. Now, if we've got big data, we generally can't store that on an individual computer. Or technically speaking, there's no specific size at which data becomes big data, but it's generally accepted that it's big if you can't open it all at once on a standard work machine. So I'm very lucky. I have a MacBook Pro because of a project I was involved with, and it was funded and given to me by the IT team. So that's a pretty meaty processing device and can hold a lot of data all at once. So it may be able to hold an Excel sheet that's absolutely full of data. So, a few 100,000 rows. Now, big data is an order of magnitude greater than that. So 10 times bigger, 100 times bigger, something that Microsoft Excel in and of itself can't open. That's when we're thinking of big data. We'll come on to what these acronyms mean later on, so DAS, SAS, IS, and PAS as well, or PAAS. People either form the acronym into a word or just say out the letters of the acronym. Okay. Now, the cloud is a great security gateway as well. You'll see when you get your BCU email addresses that you can access Office 365 online to get student emails and join teams, but also you can get access to BCU services, our general student information portal and things. But the cloud forms our security gateway. So no matter what I'm logging into as far as the BCU services are concerned, whether it's my emails, Teams, my online storage, my student printer service, it doesn't matter. It all sits behind the Microsoft security gateway. So I have to log into my Microsoft account to then get to everything. But once I've logged in, that's all fine. And then there's testing as a service as well. If you're testing code and say developing a new website or adapting your website and you want to see what it'll look like, you put it up into the cloud. You don't mess around with the computer that's currently running the website. Otherwise you'll break it. So let's just talk scale for a minute. So cloud is $1 billion industry, worth about $67 billion in 2015. By 2020, it was projected to be worth 162 billion. That's actually an underestimation. It's thought now. They're still trying to estimate and calculate exactly what it was worth in 2020 because of COVID. The massive uptick in use of cloud services and storage and things. A lot of it, service providers gave parts of their systems away for free to try and get people used to using them so that they could then, after lockdowns, retain them and charge them for services. 74% of tech CFOs say cloud computing will have the most measurable impact on their business in 2017. Gartner, who is a business insights expert, predict the worldwide public cloud services market would grow 80% to 2017. We're talking massive growth figures. Okay, as I say, it's very hard to quantify exactly the size of it and the scope of it because it's a portion of a much larger organization, say Microsoft, Amazon, Google, for instance. So it's very hard to narrow down exactly what it's worth. What's funny about the cloud is it's being questioned at the moment. Now, this is just for your own information rather than as relevance to the exam or things, but just to keep an open mind. The cloud is being seen at the moment as a quick solution to a problem of you don't want to maintain your own computers, you want to cut costs, you want perfect uptime for your website or your service or your system, so you put it in the cloud. But the thing is, it's estimated now that cloud systems actually cost twice what it would cost to run a server farm for your own company. So if Amazon, instead of using the cloud for their sales system, their website system, and instead just ran their own server farm, it would cost them a lot less, but it might not be as reliable. So there is a big important point there as to what's the value in having a reliable system that's easy to maintain and that you don't need too many IT engineers to sort out the parts and hardware problems for those machines. You can just have a lot of cloud engineers and cloud technicians. So cloud computing gives you the ability to what we call spin up any server you require on demand, which meets your needs and requirements. It's generally flexible and dynamic. So in AWS, if I put a program up there, an AI model, and said, run this, it might run across one computer. It might look at it and go, I can run this really quickly across 4 computers. So each of those computers will do a quarter of the work, but they'll do it 8 times as fast because it's spread the load. And that's the way the cloud works. That flexibility in there is incredible and gives you the possibility to do things that you just wouldn't have been able to do in computing 10 years ago. So it removes the requirement for you to purchase racking space and your own servers. The biggest problem with having lots and lots of servers was just maintaining them. Generally, it was a huge cost in terms of air conditioning for lots of companies. So if you have a server, a set of computers that form a server, then putting that in your office in Birmingham, in London, in wherever you are really in the UK, you need to have a cooling system to make sure that's not getting too hot. So all of a sudden you've got an air conditioning unit inside a server room or a cupboard or something where your server is held. Air conditioning units are filled with water and sometimes leak. That's a massive risk to your organization. So all of a sudden you've got a problem, potentially, if the air conditioning unit goes wrong, doesn't cool, leaks, breaks. So you've got an extra cost there to maintain. You're also putting out more gases from having an air conditioning unit of your own into the environment because it's harmful CFCs. So what the cloud does is these cloud providers have come up with more clever ways and cost-effective and energy-efficient ways of running cloud storage systems without being as damaging as individuals running their own servers would have been. Generally, the accepted way of doing this is that they realized a couple of years ago, rather than building cloud storage facilities all over the world evenly, it's far better to just have a really good connection to cloud service storage centers in very cold countries, because you don't need to cool down all those computers with as much air conditioning if it's minus 20 degrees outside in the top of Norway. Okay, so they got clever about this. So AWS started out with us using redundant space and resources on Amazon services. So different servers are available based upon different requirements. So these cloud services, you can go on and specify, I need a really powerful computer, or I just need a simple computer that's just reliable. I'm just hosting a website. Okay. So you can specify what type of machine you'll need or how many you think you'll need, and then let the cloud do the work for you. The ability to provide low-cost storage on remote hardware. Most people in the room will use cloud storage, so you've got Dropbox, you might have come across Google Drive, iCloud, OneDrive. There's a whole host of these things. I take it, is everyone using some sort of online backup system or drive system? It's generally given to you if you've got an Android phone or an iPhone as well. So these offer scalable storage as well as the ability to archive and backup data in different locations worldwide. And it's generally a fraction of the cost to increase your storage, say on Dropbox to 1 gigabyte, 1 terabyte, or whatever, than it would cost you to go out and buy a terabyte hard drive to physically store your data on and keep safe yourself. So if you've got a massive amount of data, so let's just explain this. I've just put up the term exabyte here. So your phone, say you've got a new iPhone, the one that's just come out this week, maybe you're very fortunate and have bought that, and that has 128 gigabytes of storage. So that's quite a lot of photos, a few thousand photos, music, all you like. So 128 gigabytes of iPhone. So if we had 1,000 gigabytes, so 10 iPhones worth of storage, then we've got a terabyte, it's called. If we have 1,000 terabytes, we have a petabyte. And if we have 1,000 petabytes, we have an exabyte. It's estimated that the entirety of the World Wide Web would be between 1 and 2 exabytes worth of data. So that's a colossal amount of data that's online. So if you had an exabyte of data, say you were Facebook, and you collected and stored offline all of the information about every person that's ever done anything on Facebook, plus what they've looked at, plus what Facebook has heard in the background whilst people have been talking with the Facebook app open, or what it's seeing the adverts, the potential things that they're going to do, the information about all their employees. What if they just wanted to do an entire backup of Facebook? That might be an exabyte of data. How would they get that to the cloud? You can't just open up Amazon and a web server and say upload, or Dropbox and upload an exabyte of data. Okay, my children's children would have passed away by the time that an exabyte of data at our current internet connection speed would have uploaded to the cloud. So what we do is there are some very big trucks called, for instance, the Amazon Web Server versions are called snowmobiles. So these are Amazon Web Server snowmobiles, and it's an exabyte scale data transfer service. So you put on an absolutely load of individual hard drive disks, all of these things into the back of this truck, and they will go and transfer up to 100 petabytes of data per snowmobile. So a colossal amount of data in one of these giant shipping containers, rigging trucks, that will then pull it to an Amazon Glacier storage system and upload it all to the cloud for you. It may seem a bit mad with data like that they're sending a truck, but they're not the only ones who do that and have done that for some time. NASA famously, if they need to transfer very large files between some of their sites at opposite ends of America, instead of emailing them or transferring them, if they've just got a very big file, they just put it in the back of a Jeep and drive it or post it from one side of America to the other, because the postal service will get their files delivered quicker than if they upload and download a massive file from the cloud. Say a simulation of a rocket going to Mars. Okay. Internet of Things. So the Internet of Things is absolutely huge. And I think we've started to realize that over the last couple of years, probably unconsciously. Now, working in artificial intelligence has been really exciting for me over the last couple of years to see what people are doing. But actually, the things that have hit the consumers the most and the biggest developments and tech successes haven't been the Alexa or Siri or you know, voice activated things, deep learning, artificial intelligence, cutting edge stuff. The thing that's been most important to consumers is the Internet of Things working effectively and proper connectivity between devices. The ability to take your mobile phone and look at your TV and go just swipe up and send something to your telly that's connected to the Wi-Fi, that's downloading your shows, that's connected up to a Sonos soundbar perhaps, that's playing music from your phone as well that it's connected to. And your phone itself being connected to a whole host of other devices in your house, whether it's your lights, whether it's your doorbell system, whether it's your fridge, if you've got one of these new smart fridges that you can look inside remotely. Okay, the Internet of Things is absolutely huge and has been one of the best technological breakthroughs in effective communication between devices in the last few decades. AI will help with some of these aspects and make them smarter, but just the sheer fact that these things are talking to each other is a massive market. So this will mean that there's terabytes of data that is constantly being transmitted. It removes the stress of on-premises data centers and allows data to be processed by multiple different services that can be available on internal systems. And again, it's scalable based upon demand. Okay, databases, big data, and NoSQL. So I sort of defined roughly the scale at which we've moved from just data to big data. The thing with databases in the cloud is that you can have massively scalable ones very easily and massively reliable and fast connections between them. So having a database that's massive is all very well, but if your connections to it and be able to pull data out from that database takes a long time, each time you need to query it to ask it for some information, then there's no point to it whatsoever because people will stop using it. A huge amount of processing power for big data in the cloud. So without the use of cloud and big data, it wouldn't be feasible for many smaller businesses to operate the way they are. NoSQL is a new buzzword. So I think some people on your job adverts would have come across SQL. I know at least someone's defined it, and we'll go on to that shortly to talk about from the job advert point of view. But NoSQL is a variant of SQL, or structured query language, that databases are written in. NoSQL is really interesting and unusual because it means that we don't need to think of our data just as a set of tables. It can be a whole host of different information that works perfectly together as an ecosystem. You could think of a social media network. So your friends and your connections that you make and the groups that you're part of, that doesn't fit into a standard Excel table very easily, or any table. You couldn't just write that information down. But if I had to draw a picture to say, okay, Kent, you're a friend of Pete, who's a friend of Gamze, who's a friend of Tololope, all of a sudden we've got a network showing that you can easily convey in no SQL, but you can't put that information into SQL very easily. Okay, so you'll probably see NoSQL listed as a required skill or an ideal skill for some jobs that you're going to be looking for in the future. It's easy enough to pick up, but it is outside the remit of this bootcamp. Okay, we've got star as a service. So star in computing is generally used as and like insert, like a wild card, if you're used to that terminology from playing cards, or just anything that ends in as a service. I don't want to spend too much time talking about these because we're going to delve into them far more from a Microsoft point of view, and it makes more sense showing the examples there. Okay, but just so that you've at least heard the headline terminology. So we've got infrastructure as a service, platform as a service, software as a service, desktop as a service or data as a service, and managed video as a service is a newer one. So, okay, just gonna, like I say, skip through these. Now, cloud service providers. There are, generally speaking, 5 major cloud service providers. Smaller ones or medium-sized ones do crop up here and there, depending on your location and what you're looking to do. But in essence, your main ones are going to be Amazon Web Services, Microsoft Azure, Google Cloud Platform. To a lesser extent, you have IBM's Cloud and DigitalOcean too. DigitalOcean is quite relatively cheap, quick to set up with, but doesn't have a lot of the bolt-on intelligent systems. Microsoft, Google, and Amazon have more of the intelligent systems, and Amazon is better suited to AI implementation. Google's cloud services are very, very quick because they design their own computer chips to work with those. But the IBM one is a bit unusual because it has some incredible services that are just bolted on for free, but that does make it more expensive. Okay. I'm not going to go into too much detail because that's an activity that I'm going to set for you to work on tomorrow. So we've got some information here about each of the cloud providers. So Amazon Web Services, AWS, is the undisputed market leader in cloud computing. So just for the quarter ending June 30th, 2016, it generated $2.9 billion in revenue. It is colossal in size. It's a little difficult to figure out how much revenue Microsoft generates from cloud computing, mostly because they like to hide their income in lots of different pots of monies and not tell everyone what their current developments or focal points are. They'll have made a lot more recently, obviously, especially given that Office 365 now works seamlessly with their cloud system. So people are naturally being drawn towards Microsoft Azure. So Google doesn't break out its cloud computing numbers at all. It's very secretive in terms of what it's doing and what it's spending its money on naturally as part of the Alphabet company. But it is growing very quickly. So in terms of advantages of the cloud, it's flexible, easy to use, cheaper than buying hardware generally, disposable, i.e. once you finish with your website or your software, your system or your AI program that you run, you just get rid of it. Done. Takes a minute for you to tell the cloud to just wipe that computer clean and you can start on your next project. It's excellent for startups, small businesses and enterprise as well. What about disadvantages of the cloud? So there's a security issue here. Given that you've transferred your data up to the cloud, is it secure up there? Who owns that? What happens if a cloud service provider is hacked? It's unlikely, but it's possible. What happens if the service is just turned off? What if AWS somehow went into administration? Or Google, like they do with so many projects, just decided, you know what, this cloud thing, it's not making us enough money. We're not going to do it anymore. We're just going to turn it off next week. You don't own the hardware. So especially from a financial point of view, in terms of your company, you're at a risk there. You don't have an asset that you could sell if you needed to. But trade embargoes. It might seem a bit odd to bring this up, but it's not altogether too unlikely that the UN and the international community impact trade embargoes on countries. So there are sanctions. You know, what if you're in North Korea? There are talks of sanctions into Russia. There are talks of sanctions in other areas of Eastern Europe as well, and actions and reactions. Okay, Iran naturally has sanctions ongoing in lots of different ways. So how would you make sure that your cloud services were protected or suitable to work in those or outside of those? The prices aren't fixed in the cloud, and this is a really important thing to get your head around as well. You're renting a computer from Amazon or from Google or from Microsoft, but it's not like you're renting it and they're saying it's costing you 50p per hour. Its cost is based upon what use it's getting. So the more that people are accessing your website, the more traffic that's going through, the more that you have to pay for, because they're having to route more services and power to that machine. So from their point of view, it's only fair, but from your point of view, that's quite hard to budget. And in fact, Amazon has so many online services and systems that people are using for lots of different things in very large organizations in the cloud, that they've had to create an Amazon Web Server pricing tool so that you can monitor exactly how much you're spending on each of the different services and cloud portal informations and data stores and stuff. The thing is, and rather hilariously, they created this tool to tell you how much you're spending, but it doesn't tell you accurately, and you have to pay to use the tool to tell you how much you're spending on Amazon. So in some ways, it's easier to just wait and get a massive bill at the end of the month for, you know, £500,000 for cloud services if you're a very big company. And the cloud's very accessible for illegal activity as well. It removes things like the digital fingerprint that makes it so easy for the legal authorities to try and track and see what's going on in the world. So here's just a list of the different services provided generally by these 4 top cloud provision services: AWS, Azure, Google, GCP, and IBM. So given these things and what their general benefits are, you can see that there is a difference between them, and it's very worth working out what's best for the service that's required for the organization you're working for if you're moving or using the cloud for a service. Okay, generally it'll be quite clear, and you won't be responsible after doing this bootcamp at least for setting up a cloud platform or for maintaining it on your own. There'll be a decision made by people who've got far more experience in the cloud services and systems and network services, but they will be expecting you to support them with that if you're taking a cloud engineering job. Okay, does anyone have any questions about the cloud or anything I've talked about so far?
Sorry, it might be a very simple question. The IoT in our course means Internet of Things. Is that related, or does it have a different abbreviation as far as our course is concerned?
IoT means Internet of Things, yes.
So in our course label, it stands for that only.
Yes.
Okay, thank you.
Yep, IoT generally is just Internet of Things. It's if you see an acronym elsewhere for IoT, it's Internet of Things. The O is always the O for of is always a lowercase. So that's what we're easily working out. If it's capitalized, then in an organization it means something else.
Okay, thank you.
Okay. So I'll introduce the activity that I'd like people to do later on today and tomorrow, well, to start this afternoon before lunch and to work on tomorrow. What I'm going to do is allocate you into groups. Probably I'll allocate you to pairs based on the numbers, because I think that would be really good for you to get to work with one another. I'm going to put up an empty PowerPoint file for each of you, and what I'd like you to do starting today, after we finish the next activity, is to research one of these cloud providers. So I'll put you in pairs and tell you which one I want you to research. But there's obviously AWS, Azure, GCP or Google Cloud Platform, and IBM. So I'd like you to create a PowerPoint presentation with just 4 slides. So 1 title slide and 3 slides of information where you detail some of the specific bits of information about each of these cloud providers. Okay, 3 slides isn't a lot, so it's going to be quite dense with information. But this is going to be a good experience for you to start building a presentation and then to get some feedback in terms of, from me, in terms of the visual aspects of presenting information and how we can do that effectively. If you've not used PowerPoint much before, don't worry, we'll be covering that more and more as time goes on, and you'll get more comfortable because we're going to be doing lots of presenting skills and preparation of slides and things over the next few weeks. So the idea is that you work together for the 2 hours tomorrow between 10 and 12 in your pairs, doing the research into each one of these core cloud providers, putting the information on slides, and then on Friday there's going to be a slot for people to actually do a presentation and just talk through a cloud provider, giving you a bit of information after you've searched them up, got some information from their website. Some of the numbers and things that I've shared today might seem slightly outdated, so go away and get more recent information. Okay, what's an extra free service or extra information, or what's the difference between, for instance, Watson and Cloud Machine in terms of IBM's offering there? What is Watson? Okay, so I'll put you into pairs later and tell you which one of these 4 I'd like you to go away and research and to create some slides, and that'll be tomorrow's activity. A bit like yesterday, so I'll be on a Teams call available through the chat to answer any questions and to make sure that there's no issues, but it will be a self-directed thing for you to work in pairs and start building up those slides. If the pair I put you in and your partner isn't available, then you can still work on the slides on your own. We won't be expecting as much or as critical if you've not got a partner to work with, but so it could be an individual piece of work, but generally it'll be working in pairs. Okay. Does that make sense, what I'm asking you to do?
Sorry, we have on the slide, we have like, let's say, several points here. So should we explore about the pricing structure, or like, or how they're different?
It's more about the specifics of a single one. But if you wanted to do comparison, you can do. But I'm more thinking of, okay, if you were Google, for instance, so GCP, just a bit of information of how you set up a Google Cloud platform, where you go to get that information, how much it might cost, what are some of the services it uses. And although we've got this table here, you could put that information in a much more clear way and then give a bit of information, say, in terms of database. If you wanted to focus on databases when you're doing your research about the GCP, then you could go, okay, you've got Google's Cloud SQL Big Table, like define what they are. Show some information about that, and then that gives you something to talk about in the presentations on Friday.
Okay.
Okay,
thank you.
great. As with yesterday, at 10 o'clock tomorrow, I'll make sure that there's a slide up explaining it and reiterating what I'm asking you to do and to build, and make sure that everyone knows who you're supposed to be working with. Okay, so the next thing that I wanted us to do was to talk about this jobs analysis work that I'd asked everyone to make a start on yesterday. And I think there's a couple of submissions that I thought were really great. If you haven't submitted yours yet, then please feel free to do that today. I don't mind about these things if they're slightly late, as long as we've got some at least that are on time. But it's generally good to try and keep the time if you can. So what I was asking you to do was to find a couple of jobs that maybe you could apply for after the bootcamp, or just maybe were just suitable data analytics and data science jobs. And then we would break down some of the technical terminology and the expectations of those, and try and see in more detail what those things meant, what it's asking of you, and maybe what you could do to get to that point. Okay, so we had a submission that was just a couple of the job adverts, so I thought it would be good for us to go through those in a minute, to break down as a group together and suggest some of the things. And then we had 2 good submissions where they'd been broken down in lots of detail. So we've got this role, which was a data scientist, and the link to the role is just here. I'm just going to widen this out and make sure we're all zoomed in so you can see. So here's the description of that. Now, I'm not expecting you to read that all right now, but just scan it and you'll see a couple of acronyms. You'll see a couple of bits of what they're expecting. Okay. Now, you'll notice that this job is specified as a data scientist, and there's a lot of information in there because they're expecting an advanced or very experienced worker. To note in particular the last sentence, this is an excellent opportunity for someone with a strong insurance record looking to move into data science following an MSc or master's or PhD, so a doctorate in a machine learning based discipline. So it would be a very exciting job to work in, but it's well light years beyond what we're covering in this 16 weeks. But there's a lot in here to unpack still that is still standard terminology for jobs. So it's important that we can understand that and make sure that you know what these things are asking for.
Yeah, most of the things did mention the jobs I found that they wanted like PhD or masters in either computer discipline or mathematical or statistical differences. If we don't have I don't have that, how do we get a chance to get a job? Should we do mathematics or the you mentioned we will be doing it in the course as well, but will they be happy with that, or to get a job we have to do something else to show the employer that okay, we have done mathematics which is needed for machine learning?
So if you wanted to get a graduate level job in data science, then you would need generally to do either a graduate level degree or in the discipline that they're asking for, or have several years of experience doing that at a couple of different organizations that you've built up the different parts of that job. Although you might not have been a data scientist, you might have been a data analyst or data engineer. So you've got lots of experience with databases and things, and in your own time learn and done some digital badges in some of the machine learning things that they would expect a data scientist to do.
Mm-hmm.
But you'll need to have experience for several years or that qualification they're expecting, generally. So it is a data science as a role, it can be tough to break into. There are every now and then roles for data science where they're not expecting as much, but generally I think what you're going to be looking out more for is data engineers, data analysts, cloud engineers, but more it's the data analyst and data engineer roles in particular, because the barrier to entry for an analyst is relatively lower. We'll come on to the difference in a couple of weeks, I think, between data science and data analytics, because there is a big difference, at least from an academic perspective and in terms of the roles as well, in what's expected. But the easiest way of trying to explain it might be the data analyst might be a pharmacist who works in a pharmacy, who's giving out the pills and having regular contact with the customer, but making sure that any combination of the pills that they're taking works and there's a reliability in the system. The data scientist might be the person who works at GlaxoSmithKline, for instance, as the pharmacokineticist, or someone who's designing and developing new drugs, so that the data analysts, the pharmacists in the Lloyd's pharmacy or whatever pharmacy it might be, are able to give those out. So that's why the data science is generally regarded as a requiring more advanced degrees or experience, because you're trying to specifically design and craft the AI models and tools, rather than the data analyst approach, which is just apply the best tools for that job. and handle the data.
Thank you.
Okay, I'll give some much more concrete examples of that in a couple of weeks, so don't worry if that just went, okay, please don't panic. So this job, we've got some acronyms in here. So rather than, I've talked an awful lot at all of you, or you're probably quite fed up with my voice. So if anyone wants to shout out, so has anyone, if you just want to throw out a definition or any ideas, any suggestions for, let's start with Python. Anyone know what Python is?
It's a very simple language to learn.
Yeah, it's a programming language.
Yeah.
Perfect, thanks, Riti. Has anyone come across scikit-learn as a term?
It is a Python library, I believe. Perfect,
thank you very much, Kamsi. So yeah, it is, and in the explanation that we have down here, we've got Python defined. Go scikit-learn. So rather than me defining it, let's go for what the person Josh has put in. So in terms of the explanation, it's a Python machine learning library. So scikit-learn and all of these things in Python, they would be called libraries. I prefer to call them toolkits because it works better with how my brain thinks and works, and you can do the same, so you in your own notes and things. So scikit-learn is like the toolkit. So if I'm going to do a job, like hanging a picture, for instance, first thing I'm going to do, obviously I've got the picture, but I need to go to my garage, I need to get my toolkit that's got my nails, that's got my hammer, that's got my spirit level in. Okay, I'm not going to hang this picture myself, try and hold it out like that and go, oh, I think it's fine, I think that's about square. Okay, my wife would kill me. So what I'd need to do is go and get the tools for that job. And scikit-learn has in it the hammer, the spirit level, the nails, the things that you need to do to hang that picture. In much the same way, if you've got your data, scikit-learn has the tools to clean that data, to get it ready for you to use standard machine learning models on, to be able to understand what's going on, to be able to visualize what's going on. Okay. We're going to be covering a bit on scikit-learn and using a couple of simple functionalities within that on this bootcamp when we do some Python programming. Okay. TensorFlow. Has anyone come across TensorFlow?
It is a library again, I think.
It is. Thanks, Gamze.
Library.
Yeah, so it is a library. It is a Python machine learning library. It's used particularly for what we call deep learning, some of the more cutting edge AI tools and techniques. It's pushed heavily by Google. So when we use Google's cloud platform later on to do some of the Python programming and machine learning that we're going to be doing, it will be auto loaded there and we can just bring it up and start using those tools and techniques if we want to. Okay. So then we've got GCPA data scientist is needed. So any suggestions on what GCPA data scientist is?
Google Cloud Platform Architect. Sorry, just guesswork.
That would have been my guess. Yep. So yeah, GCPA data scientist. You know what? Let's. I'd skipped over that one when I was doing my preparation. So let's just get the definition from the horse's mouth from Google, as it were. Sorry, I lost my web browser. So GCPA data scientist does seem to be a Google Cloud Platform, something to do with Google Cloud Platform, being an approved data scientist with that, so doing their own qualification. Joshua, yeah, so it's not just me, you struggle to find a definition too. Good, okay. Perfect, thanks for defining all the other things so well. So let's have a look. It's needed for a truly innovative organization. Any organization that calls themselves truly innovative is not innovative at all. It's just, they're just a company that uses tech. It's been a very long time since I've seen true innovation in any organization. I've worked with quite a few over the years. So, but they like to call themselves innovative. And they want to do algorithmic trading. In essence, does anyone know what an algorithm is?
do certain to do things in a certain way?
Yeah, just a set of ordered steps that aren't ambiguous, so tell you exactly what you need to do in order, and is perfectly well defined, so that if you follow that algorithm again and again and again, you'll get the same result. So often the algorithm we use when we teach, and I teach this to first-year computer scientists, is making a cup of tea. So the algorithm might start with fill kettle with water, boil kettle, fetch cup, get tea bag. A set of ordered steps one by one, so that you can recreate that. That's not ambiguous. Yeah. So that's all they're talking about, that they want to use a ordered set of steps that's going to follow exactly the same way to do insurance. Fine. Okay, let's skip on a bit. Moving all their tech to Google Cloud as part of a new partnership with Google. So they've spent a lot of money on that. Okay. But it's all back to what they're looking for is you being comfortable working with Python, using scikit-learn, TensorFlow, and experience with cloud environments, ideally GCP. Now, it's very easy for me to be critical and to look at this from the sidelines, but you can get experience with Python, comfortable with Python, scikit-learn, TensorFlow, and algorithmic thinking. You can do all of that without a degree. Very easily, actually. In a couple of years, you could upskill to the point where you were classed as experienced working with cloud environments. If you were part of a company that partnered with Google Cloud Platform and used GCP. If you weren't part of a company using GCP, you'd have a slightly different experience with it. So it would be different when you did go and work for this job. But just on reading the job explanation, I can't see a reason that this data scientist would need a master's or a PhD in machine learning. Okay. So there's more information they're not telling you on here, given that that's a requirement they've got. Does everyone feel comfortable with just breaking down just those main terminologies? What started as potentially a scary job advert asking for all these, lots and lots of things, actually whittles down to, can you program in Python? Can you use machine learning? And are you comfortable with the cloud? Okay, let's go to the next one, data analyst role. Great. So the client's looking to recruit an HEO data analyst to join new and expanding data insights team. Okay, so again, just have a quick scan down, see if any acronyms or words jump out at you. They like the word insights. There we go. So responsibilities and essential skills. That's the stuff that we were going to be focusing on. So responsibilities, working collaboratively with other data scientists. Okay, yep. So just being able to work comfortably as part of a team. We're back to that professional set of skills that we talked about, stuff that we are going to get you to do a bit of just to get some experience over the next 16 weeks. But that largely is a very personal thing. Working closely with customers and other professionals. Strong collaborative working environment within the team. Practices like version control, unit testing, code review, and well-documented applications, things that are currently done very badly in machine learning. Machine learning is going through a bit of an upheaval at the moment as an advanced discipline, and people are having to learn in machine learning the same stuff that people from software engineering had to learn 30 years ago. So we're relearning lots of stuff that software engineers and experienced software architects know inside and out. Okay, but hopefully you're looking at these and thinking those responsibilities don't look like too demanding at all. Does anyone think that that's beyond you, or any of those look really hard to be responsible for? Okay. So essential skills. So data visualization. So we're going to do some data viz with Python in particular. R, has anyone heard of R?
I remember that it is a language for statistical computing.
Absolutely. Brilliant. So Python is a general programming language that you can do lots of different things with, but it's predominantly used for AI. But you can absolutely code websites and all sorts of other stuff in it. It's quite big and flexible. R is a bit like Python, but it's nearly always just used for statistical analysis. And remember I was saying about scikit-learn being like your toolbox. Sorry, so although R is a different programming language to Python, it is a bit similar in that there's lots and lots of toolboxes and standard statistical things in R, but because there's all these standard statistical things, it's preferred by statisticians and people who work in data science from a stats point of view rather than from a machine learning or a programming point of view. So it's just subtly different, but it does a lot of the same stuff as Python. Has anyone heard of Power BI? So don't worry if you haven't. Thanks, Josh. Perfect. So it's a Microsoft tool for visualization. So it's just, and you'll see an example of that whilst we're looking at the Azure Cloud Platform and some of the things you can do with that. But Power BI is just Microsoft's way of having a programmable dashboard or data visualization tool. So you can do it as a drag and drop system where you say, okay, I'm making a visualization for management. They need to see the sales history for these top 10 products across the country and to see which areas of the country things are selling better in. So I need to make sure I've got a nice map of the country, then a bar chart telling them which products have sold best, then a line chart that says here's what it sold for last month, the month before, month before, month before, month before that. Oh, and then this month we're up. So a few line charts, bar charts, some statistics or a table there, and a map of the country. Put those all together as a data representation, and that's a dashboard. It's very easy to make a bad dashboard. It's hard to make a very good and informative dashboard. Power BI is a standard tool for being able to just shove these different bar charts and line graphs and maps and tables and things all together to make a nice, intuitive and easy to update data visualization. It's not by any means the most widely used, but it is well integrated with other Microsoft services. So if the company uses Microsoft Azure, it's likely that they'll want to use Power BI. Then we've got Tableau. Has anyone come across Tableau before? Yeah, I'll just throw this up. Tableau, there we go. So it's just another data visualization tool where you can create dashboards and intuitive things and analytics. There's a lot of free available information about how to create these charts and representations online, but from a public point of view or from a student point of view, once you got your BCU student email addresses, you can download Tableau and mess around with it a bit, get some experience with it, because it may be that we're useful and you'll be using that later on in a job. So it's good to have done something with it. There are some courses online, so you can learn Tableau with free training videos, or there's a Tableau certification. It costs a bit of money to do, but could be important for you later in your careers. So something to be mindful of. Okay, advanced analytics methods, for example, machine learning. We're going to be doing machine learning over the next few weeks in Python and thinking about it from the Azure Cloud point of view. It might be that you want to make sure you're more rounded and have understood a bit more about machine learning than we cover on this course. That's absolutely fine. There's loads of free, great explainer videos, information online for that. but it's best once you've got your base level, then you can upskill and learn and digest more information out there, rather than you going out at the moment and saying, okay, I need to learn about machine learning. I'll just type machine learning into YouTube and see what comes up, because it's very hard for you to trust the information that you're getting then. And they want you to be building dashboards. Path of least resistance here would be Tableau for doing that, creating dashboards. So might be worth you at the end of this session having a quick look, seeing if you can download it for free through there as a potential student, or through the public use, and mess around with some of the free open data sets they've got. And people will have put YouTube videos online for how to do some basic stuff with Tableau too. Okay. So is everyone feeling comfortable with how we're breaking down these job adverts? And have you come across any terms or acronyms of things that you weren't familiar with before or want me to explain? Thanks, Josh. Yeah, all good. Okay. So we had another submission from Mark here, where you found a trainee or junior data analyst role, which I think was a really interesting one, actually. So for e-gas and electricity, I possibly wouldn't apply to that right now, given that I haven't checked, but it's very likely that e-gas electricity limited will not be in business in a week or two's time, based on the current fuel crisis situation, unfortunately. But we could still look at their requirements there, and it's likely that if they were going to recruit someone, the company that's bought them out will have to go and recruit someone. So we're just going to jump straight from the skills and requirements part to Mark's breakdown of this, because you've gone into a lot of detail there, Mark, so I think it's worth just acknowledging that. So in terms of you want some understanding of SQL and relational database design. So we're going to do a little bit of SQL and database design, but it's very easy to pick up more. And you've perfectly showed where you can get a digital badge from it, which you can then stick onto your LinkedIn account. Okay, so it's a short course that takes about 14 hours. I'll share this out, the link to this, worth having a look, and potentially going away and doing yourselves if you're interested. Okay. The next thing, a good knowledge of Microsoft Excel and functions, VLOOKUPs, pivot tables and things, all stuff that we're going to cover on our week with Excel, and when you go and do the Microsoft Excel certification. Perfect. Experience of Microsoft SQL Server, where you're going to be using Microsoft SQL Azure Server later on, so that won't be a big surprise at all. But it's all, if you can use SQL, well, you can use SQL Server. So there's a lot of data handling with this job. They want you to be working with databases a lot. The last thing, the thing that will be difficult in terms of the skills, is they're expecting knowledge of C#. Has anyone heard of C# before?
Yeah, I have done a bit of work. I have done in Windows Mobile.
Yep. Great, thanks, Meeta. How would you describe C#, or how would you compare it to Python?
It's verbose. If I compare, it's more like they have just copied Java and added Microsoft libraries. That's what. Again, I did it like 15 years ago. So Windows Mobile, I think 2003 or something. I don't know, or maybe yeah. So yeah, so I found it just like Java or C++, but the simplified form with Microsoft libraries. Yeah.
Yeah.
So it's
if we had to rank them, we're teaching Python because it's very easy to pick up and show examples of things. C# is a bit harder to pick up, but slightly easier than Java, which is one of the most widely used programming languages. C# is quite popular, but it's most popular when you're integrating with Microsoft systems. And because they want to use Microsoft SQL Server and things, they want you to be comfortable with that, which unfortunately that does sort of rule you out from this course point of view, but it's a long-standing programming language. There's loads of free online courses, and once you've learned one programming language, you can generally pick up others much easier than you picked up that first one. Because if you get comfortable with Python, then it's all just about in your head going, okay, how do I do the same stuff in C# that I can do in Python? Oh, I can see it works like this, it does that, job done. Okay. In the same way that if you've learned a musical instrument, it's generally easier to pick up another musical instrument. Data analyst for DPD. So they're looking for some of the same stuff, really, SQL and a lot of professional skills. So they want you to create and maintain data pipelines for analysis and reporting. And I think Mark's absolutely hit the nail on the head here. So I suspect that the data will be captured via Excel, and a good knowledge of Excel and its functions will be required to manage that. DPD have one major machine learning problem that they need to solve, and they constantly need to solve it. And it is that they need to find the most efficient route to get parcels, and in particular their trucks, if they've allocated those parcels to trucks, those trucks along their routes and back. So they need their trucks to sit in the least traffic and getting the right ordering of places to drop parcels in. The ordering is generally seen as a solved problem. We know how to do that from a computational point of view and find out the best ordering with which to go and visit 10, 20, 100 places. That's not hard. The hard bit is accounting for traffic that may change day in, day out, every hour. As soon as there's a crash, that's really hard to predict. So that requires a lot of insights, analytics, and understanding, and that's what makes it a hard machine learning problem for things like DPD. So they want you to use Google Data Studio. It's free software, so you can download that, and that will do some of the work for you. And as Mark's already pointed out, you've got a Coursera digital badge in Google Data Analytics, which can be done nice and easily in your own time. They want X and SQL competency. So we're back to this Credly digital badge with a short course. You might need a bit more than that, but it's probably worth having a conversation with them and seeing what they need you to be able to do in SQL. And then GCP knowledge is advantageous. So yeah, another GCP fan. So you need to learn about and use general Google Cloud Platform services. Whoever's researching about GCP will be able to tell you about some of these when you're presenting on Friday. Okay. So the big thing is just not panicking when you see a job advert that's asking for a lot of stuff, or if they're saying they want experience or a proven track record or this or that. Just break it down bit by bit, see what the acronyms mean, and then try and draw that back to something you do know about or understand how you could learn it. And if there's lots of ors in there, so experience in one or more visualization tool or library, if you've done some Tableau, you'll do some Matplotlib and some Seaborn when we're doing data visualization anyway in Python. Okay, but maybe you want to get some experience with Google Data Studio. It's all about looking at what the adverts are all asking you to do and then seeing what free or quick, easy ways you can upskill in those is after we've given you a baseline foundation from the bootcamp to then build yourself up more. Every organization is going to ask for slightly unusual or weird things that are suited to them and that they think is normal that everyone does. But don't panic, just build yourself up bit by bit, apply to other jobs, get in the interview, and then see how it goes. And it might be that what they thought was important, you know, lots of visualization tools or library, if you can go in and say, well, I've used Tableau, I've tried that myself, I've done a bootcamp that taught me how to use Matplotlib and Seaborn really well, then they might go, well, that's all you need. That's not so important. What we actually want is you to be, you know, a professional working person, and you can convey that at interview well. Okay. Does anyone have any questions? Perfect. So we currently have 6 of you on the call at the moment, but I know a couple of you have been very quiet, so I don't know if you're just listening in the background, if you've got other things that you're doing. Perfect, thank you. So what I'm going to suggest is that everyone individually, I'll allocate you to groups, but just on your own, start to go away and do some private research on whichever of these cloud providers I give you to go and look into, and think about what area you might want to go and research. If you're interested in AI and I give you IBM, maybe you want to go and find out what Watson is. Or if I give you Microsoft Azure and you're interested in databases and data storage, and go and find out what some of these things are. Okay, I'll make sure that the slides are available in Microsoft Teams for you all. So let's get this all written down to make sure that we've got everyone allocated properly. So in the call we have Kent. I'm going to give you AWS. Joshua, I'm going to give you Azure. Ritu, you're on GCP or Google Cloud Platform. Mark, I imagine that you're on a call today, I believe. So from what you said before, so I'll put you down as IBM, and we'll work around that. I'm very sorry, Teams isn't showing me your names. Yeah, don't worry, Mark. You can pick this up later on, so don't worry. If I just so I'm gonna have to put the display names that I've got here for the last 2 of you that are showing us present. Sorry, for some reason it's not showing me your names this time. So I'm gonna put you as IBM, and Maram, I'm gonna put you down as AWS as well. Okay. So we've all got allocations in terms of the cloud providers. So first of all, just Google those, search them, go and have a look at their websites, get some information about their backgrounds. Maybe you want to read some forums and some reviews that people have done and recommendations, and pick an area that you're interested in, whether it is the computing, storage, database, AI, analytics, whatever. Pick an area that you're interested. Oh, sorry, I've missed you off the list. So I'm going to allocate you, Gamze, to Azure. In fact, I'm going to change that. Sorry, Gamze, I'm going to change that, not from Azure. I'm going to change you to GCP, Google Cloud Platform. Reason being, we do need to understand a bit about Azure, and it's good for you to do some own independent research, Joshua. But I'm going to be talking a lot about Azure next week anyway. Okay, so everyone's going to do your own research to start off with, get comfortable with who they are, what they provide, what services they do that interest you. Start working on some slides in your pairs tomorrow during the session, and prepare to give your presentation on Friday. And that would be will allow up to 10 minutes. I'm not going to be too strict on the time, but just time for you to practice just talking through a presentation set of slides. And I'll give some pointers on slide design and things on Friday. Now, it might be that we spend the first hour where I look through and give some pointers on slide design, and then the second hour on Friday, people actually get to present and talk to the slides. Okay. Please don't panic about it. Obviously, it's not marked, but we're all going to be doing things that feel slightly uncomfortable to us to start with over the next 16 weeks. But I promise it is all for a good experience and a good cause. Okay, so what we'll do, I'm going to stop sharing my screen there. I'll make sure that the slides are shared through Teams to everyone so that you can all access those in the class materials folder.
By the way, Ian, sorry, how can we watch these videos again?
That is a brilliant question, Gabsy. So what I'm going to be doing is taking the recording from this session and uploading it to my work YouTube channel. And then I'll send the link out and share the link out through Teams to say, here's the links to these 2 videos from Monday and from today.
Mm-hmm.
And I'll do the same for Friday. Once you've all got BCU email addresses, it won't be an issue at all. And then I'll take the videos off the YouTube channel so that we're not sharing information, you know, wider than here for all of you. But in the short term, it will be a a stopgap, and it won't be, you know, it won't be shared on YouTube's homepage or anything. It'll just be, I'll give you the link to those files.
Okay, thank you.
You're welcome.
I missed the very first session. I think that was the onboarding session, or before the actual start date. There was one session I missed that. Would you be able to please upload that? Or if it will be uploaded later, then it's fine. But
no, I'll get that uploaded. Tell you what, because I'm finished with all the presenting and things that I have to do, so I'll get working on that right now and get those uploaded to YouTube and then share the links out. That was a partly introductory, but also partly just more employer focused talk about the role of data science, data analytics, really, and its position over time, how that's changed, and what people need to be able to do.
okay, thank you.
Okay.
Ian, can the videos not be made downloadable because I want to create my own repository on my own home PC?
Yeah, sure. So the easiest way to do this, let's think. So you can download them from Microsoft. Well, I can download them from Microsoft Stream, and I believe you as students, when you've got your BCU email addresses, can. But so what we'll do in the first instance, Mark, I think, if I'll download them so that I've got a definite copy of them, and then once you've got a BCU email address, either you can try and download them from Stream, or I'll upload. If that doesn't work, I'll upload them to my OneDrive, and you can download them from inside BCU onto your own computer. I don't want to just download them now and send you a link or upload them to OneDrive just because of the security issue there. But are you okay to wait a week to get that working?
Yeah, no, it's not a problem. It's just so I can keep a repository of all the coursework and meetings at my home desktop.
Yeah, same for everyone else as well. So because after the boot camp, it'll last a few months, the BCU email address, but it will lapse after time. So it'll be worth it, like Mark's suggesting, have your own personal repository if you're fine for space.
Thank you, Ian.
Okay. And then the subsequent tasks exactly as they were.
Okay.